So before I took up the post as race officer in Falkirk, I had a primary 5 class and we used the Ironman. So before I started that with the class, I had the STEM folder already made up. I'd had a look through, I had a rough idea of where I was going to go with that. And then as soon as I read the first page of the novel, I realised that there were so many more opportunities than what I had planned for. So straight away, the description of the Ironman lends itself to doing a visualiser of what he looks like standing at the top of the cliff. So we did that as a class. Then he falls off the cliff and scatters all over the beach, not giving too much of the story away for you. So there was another opportunity for a visualiser. We looked at the language that was used in the first couple of pages of the book as well. So as he was falling down the cliff, all they used was the word crash over and over and over. So we learned about onomatopoeia and what words we could replace that with to decide whether that was a better option than the author had used, or whether we were happy with the same word being repeated over and over again. Did it have a better impact, and why we thought that. We also looked at adjectives and similes to describe the Iron Man as he stood at the top of the cliff and what he looked like when he was scattered across the beach as well. The next step from that was for the children to make the body parts of the Iron Man in groups from junk modelling. After we did that, we then designed a floor mat for our B-bots, our programmable robots that we have. So the children designed a beach scene on their floor mat, and then they had their B-bot ready to program to reach each of the junk modelling parts. So this is one of the floor mats that I had made for the children in the grid. So the size of the boxes has to be exact for the B-bot to fit on, and you can get those. I just got these ones on Twinkle and stuck them down. As I explained, the children would draw a background onto that. So there was a beach scene for the Iron Man, but you can make them into anything that you want. I just keep this one as a wee master to show. And then they had their B-bot here, their little programmable robot, and if you place that on where you wanted it to be, you just need to make sure, if I wanted to go from here to the top square, I would just put forward 3 times. So 1, 2, 3, and go. And you'll see that the size of the B-bot fits exactly into the box, and he would stop there. You just have to make sure after every instruction you press clear before you move on. And it's as simple as that. So when we were doing our Iron Man and the children had made their body parts out of junk modelling, theirs would obviously be much better than what this is, but this is just to show you. If they were given their instruction, can you get from the eye to the ear? So they would have their B-bot starting on the eye. We would press clear. We would talk about, so we're going to have to go 1 pace north, and then we're going to have to go 2 spaces east. And to do that, you have to go forward 1, then you have to turn right, and then you have to go forward 2. So we'll try that. Forward 1, oh. Forward 1, turn right, forward 2, go. Perfect, and we reach the ear. For maths related to that, we decided to look at direction and compass points. Now obviously, if some of you are familiar with B-bots, you'll know that they can only move forward, backwards, left and right, so they're a bit restrictive. We were only then looking at north, south, east, west. So the more able children used a Lego man to do their, I want you to get from the arm to the eye, how will you do that? Or can you travel 3 steps north, east to reach such and such? But the other alternative that we had for, instead of just doing the floor mats, was a grid that the children had in their maths jotter that they had to draw the individual body parts on and write instructions, and they were basically saying, so start at the eye, if you travel 3 steps east and then 4 steps south, where are you now, sort of thing. So we were tying maths and technology in with that together. To extend on the technology side of things, we also used the Hour of Code, and we used BB8 to programme, and that's just an online programme that you go on to. It gives you the questions and you answer block programming how you get from one thing to another, and it takes you through advanced levels. So again, you're working at your own level and extending that learning if you are able to. We also made straw hands from straws, but then it was the pull string so that the hand comes up like this. There was lots of discussions then around the body and how things work and how things are joined together, and the bones within the body and the skeleton. We looked at magnets and magnetic properties and why some materials are magnetic and some are not. So we looked at different types of metal. As part of a homework task, the children had to make their own robots that had at least one moving part. So your engineering side was brought into that there. And then the children got to bring them in and showcase them to the rest of the school and also to the parents. The children themselves asked, when we were doing the direction side of things, we went outside, we were blindfolded, we did lots of compass points work, and we did lots of, instead of just saying 2 steps forward, we make that more difficult, 2 steps north. We're constantly having to think about which direction is which. They then naturally made the link to previous learning and asked if we could tie in coordinates. Because everything that we were doing was on grids, they said, well, actually, you could be saying move 2 steps north and 3 steps east, but you could also be saying which body part is at 4-3. So they were linking their prior knowledge to what they were doing now. Everyone was very engaged in their learning, very motivated to learn. It made my life a lot easier because it wasn't just, oh, we have to do maths at 9:30 on a Monday morning and our literacy is after break time. My whole curriculum became the Ironman. So as a teacher to plan, it was just so easy and so fluid, and the children got so much more from it. Positive feedback from parents came constantly. So at parents' night, one parent had said that their daughter had gone home, and the mum had said, oh, what did you do at school today? And she said, oh, we didn't do any work, we just did fun stuff. And she said, oh, right, okay, so what was that? And she's like, well, did you know that onomatopoeia means, and she went on and on and on. And she said, well, I thought you didn't do any work today. She's like, oh, we didn't, we just did the Ironman. So the fact that they were feeling that what they were doing was fun meant that it wasn't an onerous task, and it was something that they were going to be more likely to retain because they enjoyed doing it. One thing that I will say is all the resources that we've got there are just guidelines. So as I've said, I had looked at the folder for the Ironman before I started and had kind of an idea where I was going, and then realised actually I've got hardly anything in there that is going to be where I'm going to go, because it depends on what the children want as well. So what I had said to staff in my own school was, as you go along, add things to the folder, use them, upload them, reuse them, share them, so that everybody else has got access to them as well. So the more that we go through these, they're working documents, they're things that we're sharing good practice from and that we can learn from and share together. So I hope that was helpful, and what I did doesn't mean that's what you've got to do, but it was just an example of how effective using STEM through stories can be, and I'm happy to answer any questions or support you with anything else that I can. Please use all the resources and access them, share them, upload your own examples of work as well, and I really look forward to seeing how you get on. Thanks very much.